welcome to our Bable Fish short presentation. I'm going to present very shortly the module that we refer to as the Bable Fish, which actually consists of many sub-modules. And I hope that you are patient to go with me through this very interesting and very short presentation. This code is the aim of this code is to connect to a PDC server, decode information from a PDC server, and have the ability to choose which data you want to present and use later on. Now our users are going to interact with what you see here as a VI, LabView VI. And to do that, to add the flexibility of being able to do whatever we want with the PDC based on the protocols available, then we had to use a DLL written in C. In particular, we are using Visual C++, and you can think of the whole project as two parts. One in Visual C, which consists of three submodules: the PDC process dialog, which is the main process of this DLL, and then we have the module 1 part of the PDC connection that takes care of connecting to the PDC and then carrying that information from the Visual C to LabView. And then we have the third submodule, which is the decode inf, and decode inf is actually sorry, the code that decodes the frames. So all these three submodules here are together. You can look at them together, all of them together, as the Visual C module of this, which is going to be saved as a DLL, Dynamic Link Library. This dynamic link library is flexible and we are able to change it. We have its code and you are able to run it by itself if you want. However, we look at the total end-to-end performance of this, which is a real-time code. That is why to interact between LabView VI on one side as a presentation layer and the Visual C code as the engine layer, dynamic link library doing all the work, we have to have an interface that has to be fast and compatible with the real-time application limitations, especially on time. So we don't want to use a technique that will delay us in carrying information. That is why we made three very important tests that took quite a while to test the differences between, and we have provided the KTH team, all of us, all my team have been provided this information, and you can have it whenever you want. It's in a report, detailed report on the code made. So we made three basic tests. One using a normal database or text file, text-based interface. One is networking-based interface, and the third is what we call ActiveX. ActiveX is a component available in Windows, and since these programs are made on Windows, then why not use ActiveX, we thought. So we made a test. However, before we decided which of these three different techniques should be used, and the tests have shown that the best and most suitable interface to use between LabView and the Visual C code was ActiveX. So we enabled all the ActiveX components, which is a very complicated issue, and we have to be very careful with that, and that's a very professional way of working. However, we need to test the real-time issue. We know it's professional, but we wanted to check whether it really fits within the real-time limitations. And it did. It showed the minimum delays. And why do we care about that? Because not only we have real-time information, we might be connected to hundreds of PMUs maybe later on, or many PDCs. So we have a lot of information to be processed. We don't want to lose time or delay time or add any more errors or dropping of any information due to the interface we are using. Hence, ActiveX proved to be really very good for real-time without any information dropped. Alright, so let's see how we run this code. Let's get into this. I hope I can get you excited with me as we are excited. We made here a start button for VI, so the user will come and start here, and we have our stop button. Once we start this VI application, it's going to call the DLL, and the DLL, for now, we are still in progress. This hasn't finished yet. It's a very complicated code, so we will show you what has been done till now with the hope that soon we will be done with the first version, and the first version will not be the final, it will be version 0.1, let's say, and then we're looking forward for more improvement on this and to connection to multiple PDCs. Alright, so now we are going to get connected from LabView to the Visual C, and then we will open a dialog box. That dialog box is going to show us that the DLL is working, and it's going to allow us to press on a button to send the command frame and get the information. As you see here in this VI, which is the PDC port VI, you have nothing. We're not connected, nothing is running now, it's empty. And here we have the user configuration to which PDC we're going to connect, the server, the IP address of the server, the port number, and the code. Alright, so once we are done with that, we are able to run the code, run the program, and see what's going to happen. Alright, so I'm going to run this now, and then this is going to invoke an event that we'll call the DLL from VI. Here we go. Here is our DLL in Visual C. As you see here, it's our DLL in Visual C called PDC process dialog. If you remember, I was just showing you the code over here of the PDC process dialog. So this code is actually running now as a DLL, and we have the possibility to ask for a command frame. So if we ask for the configuration frame, from the PDC, now we're running and waiting. We have many processors pending, and we're connected. If we ask for the configuration frame, we're gonna get information from the PDC. Here we go. There you go. Now the information has appeared in our LabView. This is coming in real time from the PDC server at KTH, and what we get first is the PMU list. And if you double click, for example, on differential as one of the PMUs, then it's going to give you the phasor parameters in this PMU. If you click on distance stop, for example, it's going to give you the distance stop phasor parameters, and so on. And then you can click on these ones, and then based on the information available on every phasor parameter, you can choose whether you want to have the magnitude or the amplitude, or the angle, sorry, the amplitude or magnitude and the angle. And then once you choose from here, the chosen data will be saved in this box. And once you save what chosen data you want, you can always go to the user configuration and also save. So now, up till now, we are able to have the DLL working with multiple parallel processing, to have multiple processes. We are able to connect to the PDC server with our own code. We are able to interact between Visual C modules, the 3 Visual C modules that I showed you over here, with LabView via the ActiveX controls, and they're working properly fine. We're connected to the PDC, we're getting all the information, so the whole engine work, this is the engine together with some engine in VI, the whole engine work has been done. The only thing to do now is the presentation layer. So we can divide this work into 3 main parts. You have the engine, which is basically a DLL in Visual C, and partly also in VI because of the ActiveX control. And apart from the engine, we have the database layer or the information layer, which is not very complicated here, but might run into very complicated levels later on. And then we have the presentation layer. The presentation layer is in VI. It's a VI in LabView, and here it is. So we can say we are done with the textual database, we are done with the engine within 80 to 90%. Of course, some things have to be fixed later on, but now we're working on the presentation layer. The good idea is that we can really get the information from the PDC, and we can really manipulate what we want to see. So what's remaining to be done now is to be able to choose from these phasor parameters the magnitude and the angle, and then from that we will have chosen data, and based on that we will decide what to display. And the interesting, very interesting point is that instead of everyone using this coming to choose which data he or she are interested in, we will be able to save the configuration. We will be able to press a button, save the configuration, so next time you come to open it, you don't have to go through all of this again. You can just simply come, open and upload your chosen data configuration, and it will work, and then it will display everything here for you. So now we are 90% done with the engine part, with the database part, and as for the presentation layer, which is in VI, we're working on it. We're nearly halfway through. but still some more additions have to be done based on connecting to multiple PDCs. And the beautiful thing about this kind of project, the Bable Fish, is that now we have the code. It's our own code. We don't depend on any other company or team code. KTH has its own code that's available here and in the VIs. So we can change it, manipulate it, use it whichever way we want. It's going to be used as a dynamic link library. In brief, we have Bable Fish that can connect to a PDC server or multiple PDC servers. In the first phase of the project, we're going to connect to one PDC. That's the first phase. Then next year, when we're done with this first phase, we're going to enhance this a step further with parallel programming techniques in order to move the algorithm to multiple PDCs. So we will have, and KTH will have, hopefully, one of the most advanced codes and modules for connecting to PDCs. That's the aim, but that's going to be started next year in this work. So for now, we're able to connect to one PDC. We showed you how to connect to it. The engine is done. It's basically these three modules here and the VI module. And after we are done with that engine, we have to present the information in a VI. So we can say we are advancing very well, and all the code is available with us. We are the ones who made it. Nobody has done the code for us, because the problem is, once you go to a company or other team, they only give you the DLL as an executable. You will not have access to the code. Now we do have the access to the code, i.e. we solved a major and critical problem when it comes to doing what you want with the connection with the PDC. Because if you are using the DLL or the executable from another company or institution, then you can only use the things that they want you to use. Now we can use whatever we want to use and whatever our imagination can imagine. So what remains to be done, as I said, a presentation layer, which will take some time because we have to be very pedantic and very accurate in how we present this information without any errors and in real time when it's flowing without any loss of information. Now if we go back to our start button here and we press stop, if you see here, the dialog box is still working, which is the DLL. Here we have a proof that the DLL is working. And if we just press this stop button here in this window, I'm just getting it there, and just want to show you how we stop here, and then the whole thing is stopped. That's it. And then we can get now everything is stopped, and we can just stop all of this. So in conclusion, we have presented the progress in the Bable Fish. There are two parts here, the code, and there is also a technical report that we have made on the previous tests that I discussed earlier about which technique to use for the real-time interface. That technical report is available with the team. You can ask whoever is presenting this video to you, or you can ask him to connect to me, and we can provide you with this report if you all decide to have a look at it. It's available. We know what best technique it is now. It's ActiveX, and we know exactly what kind of coding needs to be done in order to get the Bable Fish working in the best way within the nowadays available technology. So we hope that this project will not only work for us also, but it will bring a lot of attention and impact on this industry and on the research in this industry as well. So from my side, I thank you very much. My name is Iyad, and I hope that you like this, and I hope that you did not get bored and you are interested in this. If you have any question, the presenter and our team will be more than happy to answer it or forward it to me if you have any further technical questions. So from my side, I thank you very much, and I hope that you enjoy this. Thank you very much, and bye for now.